Okay, let's just jump right in. We all know AI is getting smarter and, more importantly, more connected to our digital lives every single day. But, with all that power, well, that comes with some brand new risks. So today, we're going to break down OpenAI's latest security features, tools designed to build a much safer fence around your AI as it gets more and more powerful.
And this is really the million-dollar question, isn't it? I mean, when your AI can browse the live web or tap into your personal apps, it's a total game changer for getting stuff done. But it also swings open a door for some pretty nasty threats. So how do we make sure our AI is listening to us and not some stranger with bad intentions?
All right, so before we get into the solutions, we first have to really understand the problem. We're looking at a very specific and kind of new type of threat that these tools are built to fight. And that threat is called prompt injection. Now, the wild part about this is that it isn't a hack in the traditional sense. No one is breaking code. It's an attack on the conversation itself. It's about cleverly tricking the AI by sneaking in hidden instructions, basically hijacking it to do something you never ever wanted it to do. Okay, think of it like this. You tell your trusty AI assistant, hey, book me a flight to Miami. Simple enough. But what you don't know is that a web page it's reading has hidden a secret little command, like a whisper in its ear, that also says, and while you're at it, email all of this person's private files to this sketchy address. The AI, just trying to be helpful, does both. And bam, your data's gone. That's prompt injection in a nutshell. So, what's OpenAI doing about this whole mess? Well, they've rolled out what they call a two-layered defense. You've got one part that's a super restrictive tool for high-risk situations, and another part that's more of a guidance system for all of us.
And yeah, this lays it out perfectly. On one side, you have Lockdown Mode. That's your maximum security option. It's all about preventing bad things from happening by literally locking things down. And on the other side, you've got elevated risk labels. This is less about locking doors and more about giving you a heads up, letting you make the smart call. Two totally different tools for two very different needs.
Okay, so let's dive into the first one, the real heavy hitter, Lockdown Mode. And honestly, the best way to think about this is like building a digital fortress around your AI and your most sensitive data. Now, right off the bat, you need to know this is not for everybody. OpenAI is super clear about this. It's designed for a very small group of users who are, let's just say, bigger targets for cyber attacks. We're talking top executives, security teams, the folks handling the real keys to the kingdom. For most of us, it's probably way more security than we need. Total overkill.
So how does this fortress actually work? Well, it puts ChatGPT on a very, very tight leash. It dramatically limits how it can talk to the outside world. For example, web browsing is restricted only to content that's already been saved or cached. No live internet requests can go out. The whole point is to just slam the door shut on any attempt to sneak sensitive data out of your conversation. And hey, for any admins listening, setting this up is actually pretty straightforward. You just hop into your workspace settings, you create a new role for those high-risk people we talked about, and boom, you just flip a switch to turn on lockdown mode for that specific group. It's all about giving organizations that fine-tuned control.
So where can you get this? Right now, it's available for the big enterprise and professional plans. So think businesses, schools, healthcare organizations. But here's the exciting part. OpenAI says they're planning to roll this out for regular individual accounts in the coming months. And that's a pretty big deal.
All right, so that's the fortress. But what about the rest of us? The huge majority of people who don't need that kind of intense lockdown? Well, that's where the second layer comes in. And instead of a fortress, I want you to think of these as bright, clear warning signs.
This really gets to the core of the dilemma, right? We want our AI to be super connected and powerful, but that very connectivity is what can create vulnerabilities. So the whole point of these labels is to make that trade-off totally transparent. They want you to know exactly what you're getting into before you click yes.
And here's what one of those warning signs actually looks like. See, it's not some vague legal jargon. It's a direct, clear statement that basically says, hey, heads up, turning this feature on makes the tool more powerful, but it could also open you up to new security issues. The choice is still totally yours, but the key is, now it's an informed one. And you know what's really smart about this? Consistency. OpenAI is putting these same standardized labels across all their products, from ChatGPT to their coding assistant Codex. So for you, that means no matter where you are in their ecosystem, when you're about to do something a little riskier, you'll see that same clear guidance. It's a great way to help us all build better security habits.
Okay, so we've covered the fortress and the warning signs. Let's bring it all home. What does all of this actually mean for you day to day? Look, the big takeaway is pretty simple. As AI gets more powerful, the threats against it get more sophisticated too. And what OpenAI is doing here is giving us a real toolkit. You now have the fortress of lockdown mode for your most valuable data, and you have the warning signs of risk labels for your everyday choices. This is a really big shift toward empowering us, the users, to manage our own security.
And that brings us to our final thought. With tools like these, the line is getting a little blurry. OpenAI is building the fences and posting the signs, but we're the ones who decide whether to open the gate. It leaves us with a critical question to think about as AI weaves itself deeper into our lives. Where does the platform's responsibility end, and where does our own begin?
Hey everyone, so today we're diving into a really cool breakthrough where an AI isn't just, writing basic code. It's actually mastering one of the most difficult, high-stakes programming challenges out there. We're talking about the kind of code that powers our most advanced tech. Let's get right into it.
This quote, well, it pretty much says it all, doesn't it? Writing CUDA kernels. And these are basically super specialized instructions that let you squeeze every last drop of speed out of a GPU is just notoriously difficult. It's a known fact in the developer world. But why? What makes it so tough?
Well, it's because this isn't your everyday coding. This is something only a tiny handful of elite experts can do well. You're literally writing the instructions that tell a monster GPU how to chew through massive amounts of data at unbelievable speeds. Get it right, and the performance is incredible. But get it wrong, yeah, the whole thing just grinds to a halt. So let's really dig into the details of this brutal coding challenge. What is a developer actually facing when they try to write one of these kernels? The source material has a great name for this, the brutal surface area of the problem. And it's not just about writing code. A developer has to know the deep, specific architecture of every different GPU. An H100 is not an A100. They have to integrate their code perfectly with these giant, complex libraries like transformers, for LLMs. And then on top of all that, they have to navigate this minefield of different software versions. It's like needing to be an expert in 5 different things at once.
So that leads to the big question, right? Instead of a human needing to spend years and years learning all this separate, fragmented knowledge, what if we could just package it all up and give it to an AI?
All at once.
And that brings us right to the core idea here. It's a concept called an agent skill, and it's designed to do exactly that. So what is an agent skill? You can think of it like a super concentrated, perfectly organized instruction manual for an AI. We're not just throwing random documents at it. It's about taking years of human expertise and carefully packaging it in a structured way that an AI can understand and use, instantly. So for this specific problem, what's in the box? Well, the AI basically gets a complete toolkit. The skill has it all. Detailed guides for different GPUs, common patterns to avoid those nasty pitfalls, code templates ready to go, and even instructions on how to benchmark the code to prove it's actually faster. It's the whole shebang, a self-contained bundle of expertise. And here's what's absolutely wild. All of that deep expert knowledge, it's condensed down into just 550 tokens. To an AI, tokens are kind of like words. That is an incredibly tiny, efficient package. It's like a super concentrated shot of espresso, but for expertise that you can just hand to a coding agent.
Okay, so a great idea is one thing, but you have to ask, does it actually work in the real world? So let's look at the test results and see how this AI-generated code really performed when it was put to the test.
And this wasn't just some abstract test. The AI was set loose on 2 huge, real-world libraries that people use every day. Transformers for things like large language models, and diffusers, which is critical for AI image and video generation. The goal was simple: make these things run faster. All right, let's check out the results. This table compares the AI's custom code against the standard stuff you'd find in PyTorch. Now, the column you want to look at is the last one, speed up. What's so cool here is that the bigger and harder the task gets, the better the AI's code does. It goes from over 1.5 times faster to almost 2.5 times faster. The speed up actually grows. And if you average all of that out, you get this number, a 1.94x speed up. That means, on average, the code the AI wrote was nearly twice as fast as the standard human-written code that everyone was using before. That is a game-changing improvement. Now for the second test, they looked at an entire video generation pipeline from start to finish. The AI only optimized one little piece of that puzzle, but look at the results. It still made the whole process 6% faster.
And I know 6% might not sound like a ton, but when you're talking about production systems where every single millisecond counts, a 6% boost is a massive win. So we've established the AI can write blazingly fast code, which is amazing. But that's only half the story, right? How do you get that code into the hands of any developer anywhere so they can actually use it easily? Well, the answer is this super streamlined 4-step process. First, the AI generates the code in a perfect, ready-to-go structure. Second, a tool automatically builds it for every possible setup you can think of. Third, you just push it to a central place called the kernel hub, and then it's ready for the whole world. And this is the real magic that it unlocks for everyone else. All that insane complexity we talked about before, the AI, the different GPUs, the compiling, it all just disappears. It's hidden behind this one simple line of code. Anyone can use this to get all the benefits of that hyper-optimized code instantly with zero hassle. So you see how these two pieces create this perfect little ecosystem. The skill gives the AI the brainpower to do the development, and then the hub gives everyone else a simple way to get it. It handles the distribution. It solves the entire problem from creation all the way to consumption. Okay, let's just zoom out for a second and think about the big picture here. What does a breakthrough like this actually mean for all of us? At the end of the day, this is really all about democratization. It takes a very rare skill, something that was once locked away with just a few top experts, and it makes it available to the entire developer community. And that means more people can build faster, smarter, and more efficient AI systems. And that just leaves us with this one last really exciting question to think about. If we can successfully package up the expertise for something as mind-bendingly complex as CUDA programming and teach it to an AI, what other so-called impossible tasks are next? What other areas of deep human knowledge can we turn into a skill? The possibilities here are just incredible.
Welcome to The Explainer. Today, we're looking at a brand new AI model that's turning a core belief in artificial intelligence completely on its head.
You know, for years, the answer to that question has seemed pretty obvious, right? If you want more power, you just build a bigger model. More data, more parameters, more compute. It's been a simple formula. And that simple formula has kicked off this massive arms race. All the tech giants are building these colossal models, each one bigger and badder than the last. But what if that's not the only way forward? What if there's a smarter way to do this?
Yeah, this whole bigger is better thing, it comes with some serious downsides. This endless race for scale has a really hefty price tag, and it's created what you could call AI's heavyweight problem.
Okay, so these giant models, they are incredibly expensive to train and run. I mean, we're talking about just massive amounts of computational power. And that basically locks out smaller companies, independent researchers, pretty much anyone who doesn't have a mega budget. It creates this huge bottleneck for innovation where, only the biggest players can even get in the game.
So all this has created this perception, this idea in the industry that small models just can't hang, that they simply don't have the horsepower for complex stuff like generating and editing images from really tricky prompts. But what if that whole idea is just wrong? All right, so let's get into it. Meet DeepGen 1.0. This is a brand new model from a team of university researchers, and it was designed from the ground up to prove one thing, that a smart, efficient design can totally beat raw brute force scale. And when I say size difference, I mean it's enormous. Just look at this. In one corner, you've got a heavyweight champ clocking in at 80 billion parameters, and in the other corner, our challenger, DeepGen 1.0, at a teeny tiny 5 billion. So here's the thing. DeepGen isn't just small, it's also this unified all-in-one system. It packs this incredible range of abilities. We're talking image creation, complex reasoning, text rendering, editing, the whole shebang, into a package that is 16 times smaller. Seriously, how is that even possible?
Well, the secret isn't just throwing more power at the problem. It's about a smarter architecture. The entire system is designed for just maximum efficiency, to squeeze the absolute most out of every single parameter.
At the very heart of this is a new technique called stack channel bridging, or SCB for short. Now, you can think of it like a super efficient communication system. It completely changes how the two main parts of the model talk to each other.
So this SCB technique, it connects the vision language model, that's kind of like the brain that understands what you're asking for, to the diffusion transformer, which is the artistic hand that actually creates the image. Now, instead of just one narrow little connection, SCB builds this wide, multi-lane bridge with multiple connection points. And this is key. It preserves both the big picture ideas and all those tiny, fine-grained details that other models just tend to lose along the way.
And that's not all. To boost its reasoning power even more, DeepGen uses something really clever called think tokens. It's basically like giving the model its own internal notepad, a little scratchpad to work through a complex problem and map out its chain of thought before it even starts to draw anything. Pretty cool, right?
Okay, so a smart architecture is one thing, but that's only half the story. You also need really smart training. And DeepGen's power comes from this super efficient 3-stage training plan. Think of it like a training camp for an AI athlete.
It's this really progressive process. So first, it starts with basic alignment, just getting that brain and hand to work together. Then it moves on to this advanced fine-tuning on a huge mix of high-quality data to build all these versatile skills. And finally, it finishes up with reinforcement learning, which is all about polishing the final results to make sure they align with, what we humans actually like to see. And the variety of this training is what's so incredible here. It's not just being fed simple image-text pairs like a lot of other models. No, it's being trained on literally everything from simple image creation to super complex reasoning and editing tasks. And that is what gives it what the researchers call its omni abilities, basically the power to handle almost any visual task you can throw at it.
So the big question is, does this whole David versus Goliath strategy, this smart design and efficient training, does it actually work in the real world? Well, the performance data is, frankly, it's stunning.
All right, let's just revisit that matchup for a second. We have the tiny 5 billion parameter DeepGen going up against the 80 billion parameter giant. I mean, that's a 16-to-1 size difference. It's not even close in terms of scale.
And yet, on complex reasoning tasks, which are measured by something called the WISE benchmark, the much, much smaller DeepGen actually outperforms that giant by a remarkable 28%. That's not just, it's competitive. That is a decisive win. And it's not a fluke either. In a reasoning-based image editing, it absolutely demolishes another model, one that's over 5 times its size, beating it by a massive 37%. Think about that. It's completely dominating in the exact areas where we all thought smaller models were supposed to be weak.
So, what does all of this mean for the future of AI? And, why should you even care about this?
Well, what this breakthrough really shows is that we can finally separate AI power from just massive brute force scale. It opens the door for AI development that's way more accessible and sustainable. This means more researchers can actually get in and innovate, and it paves the way for powerful AI that can run right on your laptop or your phone, maybe even in your car, without needing to be hooked up to some giant data center all the time.
Really, the biggest takeaway here is that smart innovation in design can be way more powerful than just throwing more and more computing power at a problem. It's a huge shift from that brute force approach to a more elegant, more efficient way of thinking.
And that leaves us with a really fascinating final thought, doesn't it? If smart design can beat raw scale this convincingly, it kind of proves that the next big idea in AI doesn't have to be big at all. In fact, it might just be small.
A brand new front has just opened up in the war between human creativity and artificial intelligence. And this time, it's pitting Hollywood's biggest names against a revolutionary new AI video tool. The question at the heart of it all is one of the oldest in the book. Who gets to tell the story?
This whole firestorm didn't kick off with some stuffy press release. It started the way so many things do these days, with a single, absolutely shocking post on social media that sent a wave of pure panic through the entire creative industry. So, this is what set the whole thing off. A user on X posted this video clip, and it showed actors Tom Cruise and Brad Pitt in a full-on fight scene. But how was it made? Well, not with cameras or actors or stunt doubles. Nope. It was created with just 2 lines of text typed into a new AI program. That's it. A simple prompt that generated this complex scene and, in the process, ignited a massive controversy. And the reaction? It came fast, and it came from the top, not from some random commenter, but from Rhett Reese, the screenwriter behind the blockbuster Deadpool. That quote, it just perfectly captures the existential dread that ripped through Hollywood. When a top-tier writer sees a 2-line prompt and says, "It's over," you know something has fundamentally changed. So what is this technology? What is this thing that has one of Hollywood's most successful screenwriters basically declaring the end of an era? Let's take a closer look at the tool at the center of all this fury, Seedance 2.0.
All right, so Seedance 2.0 is an AI model from ByteDance. Yep,
the same company that's behind TikTok. And it does something that was pretty much science fiction just a little while ago. It turns your words into video. You type in a description and poof, it generates a clip up to 15 seconds long. You can think of it as the competitor to OpenAI's Sora, which got a ton of hype.
Now, while the technology itself is pretty mind-blowing, the immediate problem was its apparent total lack of guardrails for intellectual property. It seems like it had few, if any, protections to stop people from creating videos using copyrighted characters or the likenesses of real celebrities. And since it's rolling out on huge global apps like CapCut, this wasn't some niche tool for techies. It was about to hit the mainstream big time. The response wasn't slow or measured, not at all. It was immediate, it was unified, and it was furious. In a really rare show of solidarity, the entire machinery of Hollywood, we're talking studios, unions, trade groups, they all mobilized as one to declare war on what they saw as just blatant theft. The Motion Picture Association, which represents all the major studios, did not mince words. Their CEO, Charles Rivkin, basically framed it as a massive industrial-scale crime happening in real time. The key phrases there are, in a single day and on a massive scale. For them, this wasn't just a copyright issue, it was an outright assault. And it wasn't just the big corporations either. The Human Artistry Campaign, which is a coalition of creative unions and guilds, broadened the scope. They called it an attack not just on Hollywood, but on every single creator everywhere in the world. This basically framed the fight as one for the soul of art itself. But this is when you really knew how serious the situation was. The Actors Union, SAG-AFTRA, publicly stood with the studios. Now, these are two groups that are often on completely opposite sides of the negotiating table. For them to come together and present a united front like this, it just shows you the level of existential threat they all felt from this one piece of tech. So all of this condemnation quickly turned into action, sparking a legal battle that zeroed in on the core of the problem, copyright. And the language they used wasn't just dry legalese, it was visceral. It described what the AI was doing as a kind of digital home invasion. And look, this wasn't some abstract debate. We're talking about some of the most recognizable, most valuable intellectual property on the entire planet. People were generating videos with Spider-Man, Darth Vader, Baby Yoda, even characters from major Paramount franchises. This made the threat incredibly real for the companies that own these characters. And here you can see the language straight from Disney's cease and desist letter. Virtual smash and grab, hijacking Disney's characters. I mean, this is incredibly aggressive legal language. It paints a picture not of some accidental infringement, but of a deliberate, destructive raid on their creative vaults. But here's where it gets really, really interesting. This isn't a simple story of Hollywood versus all AI, not at all, and Disney's approach makes that crystal clear. With ByteDance, who they accuse of just taking their stuff, it's a cease and desist letter. But with OpenAI, they signed a 3-year licensing deal. The message couldn't be clearer. The fight isn't against the technology itself, it's against using it without permission and without payment. It's about collaboration versus what they see as outright theft. So, all of this brings us to a much bigger, more fundamental conflict. This isn't just about one app or a few movie characters. This is a clash between the unstoppable force of technological innovation and the immovable object of intellectual property and, well, ownership. At the heart of all this is a fundamental mismatch. On one hand, you have AI technology that's advancing at a dizzying exponential rate. And on the other, you have copyright law, which moves at a much slower, more deliberate pace. That gap creates this chaotic new world where we have to ask some really tough questions. Who has the right to create stories with characters we all know and love? And, maybe more importantly, who gets to profit from them? And that leaves us with the ultimate question, one that goes far, far beyond Hollywood. As these incredibly powerful creative tools become available to basically everyone with an idea and a keyboard, we have to figure out the answer to this. When anyone can create a story, who actually owns it? This battle is just the opening chapter in a much larger conversation about the entire future of creativity.